Hello friends, welcome to my channel. Today we are going to look what is scalar UDF inlining. So basically today's agenda would be, initially we would look like what are the issues with the scalar functions, and then we would look into what is scalar UDF inlining. Okay, for this demo I am actually using 2019 developer edition as my SQL Server instance, AdventureWorks 2019 as my database, and Management Studio version 18.10 as my SQL editor. Before jumping into all these things, I would like to share two links. All right, one is from the official Microsoft, and second is from SQL Check. Now, why I want they would give actually more detailed insight on the scalar UDF inlining. And apart from that, on Microsoft site, basically they have also listed down the requirements for your function to be an inlineable function. So basically it's not that scalar UDF inlining Microsoft has given this added this feature, but for that, to take an advantage of that feature, your function should actually follow this requirements. So if your function are following all this requirement, then only your function is considered as an inlineable function and it can take an advantage of scalar UDF inlining. Now, what is scalar UDF inlining? So as you can see, scalar UDF is nothing but it's a new feature has been added by Microsoft in its intelligent query processing suite from 2019 onwards. Okay, so please go through this websites and gain some more detailed knowledge, theoretical knowledge on this. So let us start with so what is an SQL Server function, right? It's a scalar function. Basically, as we know, scalar function is nothing but it actually accepts one or more parameter and then process the code we have written and then returns the output in a single value output, right? So why we need this function? So for example, if we have a very complex logic to be implemented at several places in an application, then scalar function comes into the picture or can be helpful. So we actually bundle this complex business logic into scalar functions and then use that scalar function across the application wherever it is needed. So in a way they are very useful, but as it is said that scalar function, whenever we use a scalar function, then in most of the time the query actually gets degraded wherever we have used this scalar functions, right? So query becomes a poor performing query. Now I can think of this, I think main two reason for this are that whenever you use a scalar functions into a query, right, that function has to be executed for each row, right, that the query is processing. So for example, if you are processing 10,000 rows or a 1 million rows, then for those 10,000 and 1 million time the scalar function would get executed. So obviously that is going to take time sometimes. If it depends on the how complex your scalar function is and what the multi-statement what the multi-level statements you have written into the scalar functions. Also, whenever you use a second point would be that whenever you use a scalar function into a query, then SQL engine would always create a serial execution plan and not a parallel plan. So that may be the second reason for degrading the overall query performance whenever we use a scalar function. I would surely take you through this in a practical way, right? So let's jump into this everything into an action. So let's jump into the practical understanding of what I am actually talking since last 4 minutes. So let me open my Management Studio. So in my Management Studio, you can see I'm using this AdventureWorks 2019 database. So initially, let me take this to the earlier version, right? So I'm actually setting the compatibility level to 140, that is 2017. With the help of this statement, I can do this. Now let me clear the cache plans and the statistics. Please don't use this into your production or development or staging environment, or that for that matter on a QA environment as well, right? This is the only demo and a demo database I'm using, so I can use this very freely. Here I have written a very simple query. I'm joining a product table with my sales order details table on the basis of product ID. and I am fetching three columns. One is the name, second is the product number, and third is the unit price. Along with that, I have used one scalar function to get a quantity, right, to get a sum of the quantity. Let me show you what is that function doing, scalar function doing. So it accepts the parameter product ID, and from product inventory table, right, depending upon the product ID and location ID, it is summing up the quantity. That's it, and returning back that sum quantity as an integer value, a single integer value. Okay, so let us run this. When I run this query, so you can see this query would take almost around 4 seconds. So you can see here, it has taken 4 seconds to process 121,000 rows, right? And when we see execution plan, right, you can see here the degree of parallelism is 0, the third item from the top. Degree of parallelism is 0, which means the sequential plan was generated and there was no parallel plan generated. Okay, let us see the statistics of this function and the query itself. So when we see this, can you see here, this is our query executed once, and for that query this function got executed for 121,000 times. So as I told you, scalar function, whenever you use a scalar function in a query, it has to execute for that number of times for all the rows in the query. Okay, so this was with like 2017. Let me change back this to 2019, the compatibility level of this database to 2019. So with the help of this function, I am actually changing this back to 2019. Okay, removing the statistics again, right, and I am using the same query now. Okay, the same query, but now the environment is 2019. Okay, let me execute this. See, this has came back within 1 second, and again the same number of rows, like 121,000 rows. When we see the execution plan, you can see the degree of parallelism is 1. So some parallel plan was actually created, and some of the use of parallelism has been done. Okay, now this is what an scalar UDF inlining. So basically we are using the same function, but in 2019, actually due to this scalar UDF inlining, the query is getting processed very quickly. I would show you the difference between the older one and the newer one surely. Before that, just understand that Microsoft has provided this query hint called as an disable TSQL query scalar UDF inlining. Now what is this for? See, basically it happens that though this scalar UDF inlining is in place, but 90% of the time it would improve the overall execution or overall performance of the queries with the scalar function. But in some cases, generally for your legacy code, right, it may be possible that instead of improving, it might actually degrade the performance. So it may take some time for you to understand the query, the function, and to again rewrite as per the compatibility of 2019. So before that, what you can do is actually you can disable that scalar UDF inlining thing onto that query. So you can add this option hint to this. So once you add this option hint to this query, like this would, the scalar UDF inlining would be disabled for this query, for this function and for this query. Okay, so let us see. Let me again remove all the statistics and plan catches. Okay, and now I am executing this query both at a time to show you the difference. Right, the query is the same, but this query would get executed with 2019 and scalar UDF inlining enabled, and this query would get executed with 2019 but scalar UDF inlining disabled. Okay, let us see what happens. Let me quickly first run this query, and then we would analyze the execution plan. So it took around 5 seconds, and both the queries have written the same number of rows like 1,21,000. Okay, let us go to the execution plan. Now this is where you would understand. So the first execution plan is for scalar UDF inlining, and second execution plan is for our scalar UDF inlining disabled. And you can see first of all that with this, you can see again the degree of parallelism is 1, So some type of parallel plan has been actually created and used, right? And the major difference is here. Can you see this block here from product inventory? So basically with scalar UDF inlining, what is happening, some type of inlining, inline table is actually created for that scalar function, and then that execution is joined with the main query. Okay, and that's where actually it is improving. So basically for the function to iterate for this many times, a type of inlining table is actually created, and then that is joined to this query, and that's where actually it is executing quicker compared to without SQL UDF inlining. And on the without UDF inlining, you can see here like degree of parallelism is 0, so again no parallel plan, and again this part of inline table is missing in without inlining, right? So this is a difference between without inlining and with inlining, and this is what we are getting the advantage of scalar UDF inlining. Okay, let us see again the statistics back here. So you can see 3 rows because these 2 rows are for our query, right? And this is our function. Okay, and you can see for the query in which we disabled this, actually it again created 1 to 1 3, so it executed for this many times, right? So this is basically a scalar UDF inlining, the improvement which Microsoft had done from 2019 onwards. Okay, now as I told you that you can disable this, but if you have a scenario that there is an SQL function, a scalar function which you have used at several places, and that function you need to rewrite because it is not improving. In fact, the all the queries which are basically part of this function, right, which are using this function have degraded. So it might be difficult for you to go back to each and every places and put this query in, right? So that's where we have a different type of implementation that just create or alter this function with inline is equal to off with this clause. So with the help of this clause, what you can do is you can recreate the function, and then you can already you are using this function at several places, but as you have done this inlining of SQL, scalar UDF inlining would not be used, and your performance for those queries would again come back. Okay, so these are a various implementation of scalar UDF inlining, how to disable, enable, and all such things. Okay, another way, like when you have a function, right, with the help of this catalog table, you can find out whether your function is inlineable or not, right? So for example, we have our function as UFN get stock. Okay, so when I use this query, then you can see here it is showing me that okay, this is an inlineable, which means it is following almost all the requirements required for the function to be an inlineable, and this function surely would improve the query whenever used with scalar UDF inlining on 2019 environment, right? So this was something related to scalar UDF inlining, and the difference I have shown between the inlining and non-inlining and all such stuff. So hopefully guys you have liked this video, right? If you have liked it, then please like it on YouTube as well and subscribe to my channel. Okay, thanks a lot for your time in watching this video, and meet you next time with a new topic. Till then, bye, take care.